All right, welcome to Chapter 10, where we do a little bit of data analysis. Today, just kind of basically this. What kind of data is out there? There's two major types of data, and then just reading some graphs, if they're good graphs or bad graphs. So first thing is, like, what kind of data is there, and who are they? Like, the individuals in a data set is just like whatever you're studying. It could be a person, an animal, or a thing that takes different places. The variables are like things that can attribute to that. We'll talk about that later, but here's the main thing right here. Is it a categorical variable or a quantitative variable? I want to do a couple of examples that are not on our worksheet right now. If I put us into groups based off of hair color, do you think that sounds more like a category or more like a quantity? Hair color. Category, right? You know, you could be in brown, you could be in blonde, you could be in red, or whatever, right? You know, what if I put us in a groups based off of shoe size? Do you think that would be more like a category or more like a quantity? Yeah, because you're like a size 6, a size 7, a size 8. Isn't that like numerical stuff? That's the types of ways that you can break data down into categories, which would be called a categorical variable, and a quantitative variable, which is usually numbers, counts, or measurements. So here's some data that they did. This is all true stuff. It's probably from 2023, so it's a couple years old. So if it's a little out of date, I apologize, but this is true data. Is this website, boxofficemojo.com, lists the widest opening domestic PG-13 movies of all time. So first of all, it's not every movie in the world. They are PG-13 movies. If I cancel that out, they're just PG-13 movies. And when they say domestic, do you know what that means? Kept it in the United States, right? So it's like all of these, here's the top widest opening. That means when they go out to the movie theater, like it's just like, hey, that's opening weekend. It's like, hey, Spider-Man is released on Saturday. It's cool. Like that's opening weekend for that. Like how much money they got. So check it out. These are the movies: Avengers, Spider-Man, Jurassic World, Avengers Infinity War, and the Twilight Saga. Apparently, again, like I said, this is from 2023, so if something more recent came out, it's not on the list. But they just ask us to do this, man. Identify the individuals in this data set. So talk with a neighbor. What is this chart about? The moral of the story, what is it about? Do you think it's about the movies, the theaters, the distributors, the opening weekend gross, or the genre? What do you think most? It could be about the opening weekend gross, but it's really like, here's the moral of the story. Usually the data is about the first thing that they listed, right? And what is the first thing they listed? The 5 what? Movies. Is there anything specific about these movies? We just say the 5 movies, or is it very specific? Yes, it's very specific. They are the top 5 widest opening domestic PG-13 movies. That is probably the one thing about data and statistics that people don't like, is you have to be specific, right? You know, you can't just say, oh, it's the top 5 movies. No, it's not, man. It's the top 5 widest opening domestic PG-13 movies. And to put it in a nutshell, the individuals is like what the data was about. The data was about those 5 movies. Cool? All the variables, it's everything else in this chart. How many do you feel that there are? How many different columns are there, besides the first column, of course? 4, so there they are. The variables are theaters, distributors, opening weekend gross, and genre. Theaters, distributors, opening weekend gross, and genre. Notice how I wrote them in like a column, because they also want us to say, is this categorical or quantitative? So let's kind of dive into that. Let's look at the theaters, and what do you feel? Is that more of like a categorical variable or a quantitative variable? Here's the shortcut. What did they list in there? Numbers or not numbers? Are there numbers? Like how many theaters it was released in? What do you think? Categorical or quantitative? Quantitative. Let's just put a Q for that. Does that sound all right? Shall I abbreviate it? That's a quantitative variable. What do you feel about the distributors? Like who produced the movie? Walt Disney, Sony, Universal, Walt Disney, Summit. More like a category or more like a quantity? Categorical, so that'll be a C. Opening weekend gross, look at all that. It's about the millions and millions of dollars that they made. Categorical or quantitative? quantitative. And then finally, the genre, action, adventure, sci-fi, romance, whatever. That would be more like a category. Are you okay with that? But here's the bad thing. That's not very hard to do. Don't get tricked into thinking every time they list a number, that's going to be a quantitative variable. Here's some things that's not on your worksheet, but what about zip code? Do you know Hayes' zip code, just out of curiosity? 67601. Couldn't that put us into this category that we live in Hayes, right? But if you live in Victoria, it's 67656 or whatever the heck it is. You know what I mean? Isn't that a different zip code? That could be a different category. Your social security number, just out of curiosity, do you know your social security number? If you do, don't tell anybody. That's a number you should get memorized before you are an adult, right? It's just one of those things that comes up a lot. But that puts us into a different category because that is your human being number right there. And your house number, telephone number, what's our area code? 785, right? You know, it kind of categorizes us. Oh, you're from Western Kansas kind of stuff. So just because it's a number doesn't mean it's not necessarily a quantity in that case. So, all right. And then here's this, a frequency table. It occurs with two columns. One column lists the categories, another for the frequencies. Does the word frequency make sense to you? It's like how frequent something happens, how often it happens, right? So like one cool experiment that we used to do was have our cell phones out, just let them sit there, turn the volume on, you know, like no muting, and see how many times we got notified in a class period. Would it happen frequently? You know what I mean? Just ding, ding, ding. It all depends, you know, but every time it dinged, you'd put a tally mark. Does that kind of make sense? You're counting how frequent it happened, how often. So here's this. They say, hey, an insurance company determines vehicle insurance premiums based on known risk factors. If a person is considered high risk, their premiums will be higher. One potential factor of like how much your vehicle insurance is, I know this is hard to talk to a freshman about because they don't pay vehicle insurance, but someday you will. But one thing that matters is what color your vehicle is. As stupid as that may be, this vehicle color versus that one could cost you more insurance because they have data that says these cars of this color get in wrecks more often than not. It is weird. It is true. Red cars are the most expensive. You know, they are the most expensive. Wildly crazy. So here's what they do. They have some research. They say, fill out the relative frequency of this. What I need is a total of all these. Could you grab a calculator and add all those up? It is not that hard to add those up. Would you believe it is tedious, though, as well. But did you get them all added up? How much did we get? It is nice to have a buddy to count them up also and see if you got, I got 216, did you get 216 as well? It is also nice to have technology do that work for you. That's why we have our computer open to kind of show you that we can do this another way. To find the relative frequency, that's basically just your percent, right? So I'll do blue. Grab your calculator. 25 times out of the 216, a blue car got in a wreck. They would like us to change that to a percent, right? That's what a relative frequency is. So remember, you have to move the decimal 2 places to the right in the first place. So I'm going to write 0.1157 down. That's what it was. You have to right in the first place to change it to a percent. Then to the nearest tenth of a percent, we need to see if this number that I have underlined should stay a 5 or round up. What do you look at? That number to the right of it. What do you think? Leave it a 5 or round it up to a 6? Round it up. So we'll put about 11.6%. I'll do one more of those with you. 52 divided by 216. About 24.0 or 1. What would you put? 0.1. It is necessary to put the 0.0 if it turned out to be 0.0. Like if they say round to the nearest tenth of a percent, you better put a number there. Don't discriminate against 0. Find the rest of them for me, please. Find the rest of them. So I'm trying to keep it real with an advanced group right here. Is this challenging to do, to find the relative frequency or anything like that? No, but it's tedious. And it is also easy to make a mistake if you type the wrong number in, right? You know, it's just like, man, we all hit the wrong buttons. So we have some technology that could do this for us. But can you see, like, Okay, you could probably tell just by looking at the frequency number that green cars were the worst in this data. It doesn't mean in overall. And you could see it that they happened the most percent, 24.1% of the time. The green cars were in some sort of a wreck. But what they want us to do is maybe look at some graphs of this. There are two different graphs. You see what I have in red? You might want to put that down also. But I'll bet you have heard of a bar graph before, right? If you have not, no big deal. A bar graph is a graph that displays like a bar for each category. So you might want to circle that. Bar graphs can only be used for categorical variables because the bars are the categories. Just like if we put you in groups and I said, let's list our hair color. Okay, I'd have so many people with blonde hair, they'd get in a category, right? So many people with brown hair, they'd be in a category, and etc. All right, so the other thing is a pie graph, but what we're doing is we want to see this data better, right? So we're going to do it with these applets. If we go to Canvas, which if we go on the agenda, do you see that there is a link right here that says applets right here? We're going to use this a lot this chapter, so you might want to bookmark it. The way you could bookmark it is to hit this star right here if you're using Chrome. And if it asks you, do you want to put it in your bookmarks tab, say yes. I can help you with that later when there's time. It's like, how do you see that? Do you see all these things that I have right here? These are like bookmarks that I have, places I go often, you know. So if you do not know how to do that, I'll show you later. But check it out. Here's what we want to do. We want to click the right applet. I will always tell you which applet to use. You're like, holy cow, which applet am I supposed to use to do this? But we want to do one categorical variable single group. Cool? And I want to take this information and put it into it. So let's talk about what this is. What would this chart be all about? I don't know. I would say like insurance. Like, what do you think? Why don't you talk with the neighbor? What is the like title of this chart supposed to be? And as a problem solver, I usually look to the last sentence in that like story, and they usually tell you what it's all about. This is about police reports for recent total loss collisions. Do you guys see that I had to go back to the front page? Sorry, I know we flipped over to the second page. We're going to take this data right here about the cars, colors, and put them into this applet and make some graphs with it. So what was this data about? I read the story, and it was like basically the last sentence. Sometimes it's the first sentence. And then here's what I got to do. I'm going to go put the category names. I'm going to list it in the order they listed it to keep it simple. Blue, 25. Green, 52. And they don't give me enough spaces, so it's not rocket science. Let me blow this up a little larger for the video audience. But you see that there is a plus button right here to add another line. So I'm going to add another line. And then I'm going to type in red. You can tab over if you wanted to, 41. Add another line. White. There was 36. Black. There was 39. And gray. There was 23. You cool with which applet I used? It says at the very top too, I know we're very new at this, but I used the one categorical variable single group. Again, if you're not sure which applet to use, you ask me, I'll tell you which one to click on. But then I want to like analyze the data, so I'm going to click this thing right here that says begin analysis. And it automatically made a bar graph for me. Let me shrink it down a little bit right here. Notice that it put them in categories, right? You know, that is the categorical data in that case. So they asked us here to make a bar chart of that. Obviously, there's nothing that we're going to draw on our paper to do this, but on homework today, you're going to have like multiple choice questions, which bar chart is proper. You could totally enter that data in. They would also like us to like make a pie chart of that, which is sometimes called a circle graph. We're a pretty smart group. Can you see that you could change it with this drop-down menu to a pie chart right here? I don't like this pie chart, though. Why do you think, this is a preview of what we'll do here in a second, I don't like that pie chart? It is correct. What's bad about it? Here's some things we don't like. It doesn't list any percents. Get deeper. This is a horrible graph. Even though it doesn't list the percents, there's something else that's just horrible. The colors. Like, if you want to represent something to be green, guess what color you should have probably picked right here? Green. Red, they did a decent job with it. It's kind of like an orangey kind of color. White, I would have left it white. Black, you know what I mean? It's like if you had the freedom to make this on your own, this was just like, hey, the standard colors. I would definitely change the colors of this graph to make it easier to read in that case. But there was no percents was another big one in that case. So if I go back to it, look what happens if you just slide down a little bit. Does it give you that frequency and relative frequency chart that we created by hand? Here's the question you've got to ask yourself. Would it have been faster for me to like do this by hand, or would it have been faster for me to put it into the applet? And on this one, it probably wasn't that hard to do it by hand. Do you know what I'm saying? But what if you had thousands of bits of data? Wouldn't it be easier to like put it into this applet and let it do the number crunching for you? Especially if it was on a spreadsheet, which you can copy and paste the data into this applet kind of stuff. So we'll learn that as we go along. So they made us a pie chart. Hey, what did it all add up to be? How much percent? 100%. And then how many degrees? Oh, if you hover over, did you see that? If you hover over, it'll do that for you, right? So we're learning some stuff. I don't use the pie charts too often on this, so I think there might be a way to click and hold it, but you can see the percents if you hover over. If you switch it back to a bar chart, if you hover over, it will tell you how many are at the top also. So green had 52, red had 41. Because what a good bar chart should do is put the number on top of it, because it's hard to tell. It's like, how do you know that's 39 or not? You know, it's close to 40. Is it 38? Is it 39? It's hard to read that, you know, by the scale. So you should, if you made one by paper, you should put the frequency on the top of it. You okay with a bar chart versus a pie graph? Cool. And then the last topic of the day, baby, is like some bad graphs. Here is 5 ways that writers use graphs to mislead you. You may hear that all the time, like statistics can say whatever they want. Like there's 3 truths in America: death, taxes, and statistics can lie to you, or you know, that kind of stuff. It's just totally crazy. So check it out. First way, omitting the baseline. You might want to put a little note to the side of what that means. Omitting the baseline means, hey, they're not starting at the y-axis. Do you see that it's in the box that says 5 ways that authors use graphs to mislead you? Omitting the baseline means they didn't start at the y-axis. They didn't start at the y-axis. The graph that I have in green is a misleading graph. Bad, bad graph. If I covered this up, which I'm going to do right here, cover it up. Doesn't it look like Group A is kicking butt? You know, it's like, yeah, Group A, rocking and rolling, because its bar is way taller than the other bars. But that's misleading because they cut the y-axis off. Sorry, I didn't mean to hit that. They cut the y-axis off. Oh, that's why. They started at 50, which what should you start at instead? Would you believe the race is way closer than you think if you start at 0, look at the bars. Like Group A's bar is definitely not that much taller. So they're trying to trick you by omitting the baseline. That's one way that they can make a bad graph misleading. Another way is manipulating the y-axis. You might want to put a note, they have a bad scale on the y-axis. A bad scale on the y-axis. They have a bad scale. Yeah. We took a moment to discuss why the blue graph is bad. Like, they totally start at 0 both times, so that's fine. But look at this. They put all of that. Is there nothing in that space? Right? It's a waste of space. It shrunk things down. The Y scale was not good enough. There was no need to do that. The highest thing was roughly like 12 or 13, so why not go to just 15 for the highest thing on the y-axis? So they just make it look like it's really, really flat in that case. So that's bad. The third thing is cherry picking the data. cherry picking the data. If you know anything about basketball, like a cherry picker is somebody that doesn't run down to the other side of the court. They're not going to play defense. They're just going to stay down by their basket. And as soon as they get a rebound, you throw it down to them because they just stayed back there to get a basket. Like cherry picking the data. And in parentheses, it's only picking data to graph that shows good things happening. They only wanted to show the good things. They only wanted to show the good. So on the purple graph, like they went, I know it's tough to read on the screen and everything, but right here, May 2020 to August 2020. I don't know what this data is. You know, it could be like a company's profits or something like that. Hey, but from May 2020 to August 2020, things are going up. You know, would you believe, hey, we're doing awesome. They just picked out that one little spot right here. We were kicking butt. But here's where that is on their overall graph, just in that little orange highlight. They picked one little thing out. From 2019 to 2020, it's true, right? Things were going up. Well, what happened after 2020? Boom, you know. They just said, hey, we're going to pick out one little spot and show it to our investors or show it to this. We're like, look at how awesome we are doing. They cherry-picked the data in that case. And then the fourth way is to just use the wrong graph. Like this is probably the most obvious. Like that graph makes no sense, right? That graph makes no sense. Why would a pie chart be a horrible thing to use for that? Discuss. Why is this pie chart horrible? Thoughts? Why is the pie chart horrible? We don't even know what this data is, so that's kind of bad in the first place. Like, what is the data even for, right? But still, regardless of not knowing, why is the pie chart horrible? Because what? Well, we don't know that yet or not. It could be, you know, I see what you mean by team A, team B, team C, right? Not quantitative is what he said. I got a little bit of that. That's okay. You can use a pie chart for quantitative data. Like we did that with the car one, you know, right? So like it was just like how many cars. So I like that. Go ahead. Team B 64%, but it doesn't even take up half the pie chart, right? You know, like half the pie chart should be what percent? Okay, and maybe I missed the beginning. Do you know what a pie chart's supposed to add up to every time? 100%, right? So I'm going to make up what this data could possibly be. What if this was 3 basketball teams' free throw percentages? Do you know what I'm saying? Team A shoots 50%, Team B shoots 64%, and Team C shoots 38% of the free throw line, right? But what they did was they still probably have the math right on these shapes of pie, you know? It's just like it's not a good graph because they may have made 50% of their free throws, but to break it down to the number of degrees that they have, it has to manipulate to be less than 50%. It's horrible. Would you agree that that just makes no sense whatsoever? Bad graph choice, bro. Don't use a pie chart when your data isn't consisting of a whole. Doesn't this make way more sense? And then the last way is going against conventions. Conventions means the normals. I know you might not know a lot about politics. Have you heard of Democrats and Republicans before? Do you know the colors associated with Democrats and Republicans? Democrats are blue, Republicans are red. Do you see the graph on the left? Horrible choice, right? Didn't I make the Republicans blue and the Democrats red? That is very misleading because someone's going to look at the graph on the left here and just go, oh, Democrats kick about. Wait a minute, they're not Democrats, they're Republicans because I used the colors backwards in that case. Shouldn't it be this way? Don't go against conventions of what should normally happen. It was also like my pie chart earlier when they had green be a blue piece of pie. It's like, what is the point of that? That is horrible. So here's 3 of them on your worksheet. Why is this a bad graph? Discuss with the neighbor. 1, 2, 3, 4, or 5. Which one do you think? Why is this a bad graph? Let's do a process of elimination. It is probably not that. It is probably not cherry-picking the data. And it is probably not using the wrong graph. What do you think about the 3 that are left over? Did they omit the baseline? Is there a 0 on the y-axis at all? So they have it, right? And I heard you guys say it. What's weird about it, though? It's upside down, right? They put the 0 up top and then this all the way down at the bottom. That's not normal. What do you think that means? It's not normal. They went against conventions, right? They went against, so you can just put like number 5 if you wanted to. You know, you can just put number 5. They went against conventions. Why did you make the y-axis upside down? You know, that's no sense. This is what it should look like. I just reversed it. It's still not that easy to read because everything's backwards. Like, that would be a bad graph also because all of the words are flipped over. But, you know, that's what the graph would look like if you flipped it over in that case. So, whatever. How about this guy? Bad graph. Talk about why. First, it was a bad graph when I snipped it out. Like the titles of the labels are hard to read, so I made them bigger. It's Arkansas football wins on the x-axis. Like that's a college, you know, Arkansas, like how many wins their football team got over years. And then the wins per year. Why is it a bad graph? Reason 1, 2, 3, 4, or 5. 2, because they have manipulated the y-axis. In other words, a bad scale on it. This is what it should look like. Because if you look at the data, like until recently when they went to the 12-team college football playoff, a team never played more than 13 games in a season, right? You know, so it's like they went up to 100 on that scale. It's like, dude, you're only going to play 13 games. Now they can play up to 15 games, but still, whatever. It's like, why did you go all the way up to 100? But why would they do that? Because if you look at that, you go, oh, they're doing all right. You know, that's pretty level. You know, that's pretty level. Not at all. They have some good seasons, some bad seasons. Isn't this graph over here way easier to tell where their good seasons were and where their bad seasons were in that case? And then the last one, baby. What do you think? Why is this a bad graph? People who agreed with the courts. Doesn't it look like the Democrats totally agree with the court all the time? Which is still true. They do it more often, but why is it a bad graph? Reason 1, they omitted the baseline because they didn't start at 0 in this case. Yep, the Democrats totally agreed more, but it's not nearly as drastic as what it's supposed to be. Cool? All right, let's try some homework. You'll need the applets, right, also, so like you'll go back and forth between that. But let's just kind of see what's going on. Let me know if you have any questions. Have a good one.